So it asks here, compare and contrast the properties of a rectangle and parallelogram. Name two properties that they share and two properties that are different. Okay? So here, I would put on here that what do they share? What do you think? If you look in your chart about rectangles and parallelograms, what properties do they have this that are the same? Opposite. Okay. Opposite sides and angles are congruent. Very good. And that's two, right? What makes them different? What about the rectangles in a the angles? Yeah, rectangles have four right angles, while parallelograms do not. There's one more. What's another way they're different? Look at their diagonals. What do you notice about their diagonals? I put three L's in that parallelogram. I put parallelogram. Misspelled it up there, sorry. Um, do not. Okay? And you can use your chart when you are answering these, right? That's not too bad. You can do that. No, yes. Hmm. I'm getting people going, I don't know about that. Okay, so what shape is this one here? That's a kite. And a kite has two sides that are next to each other that are equal, but the other two sides are not. What's this one here? This one's a trapezoid. And that's because we have one pair of parallel sides. These little arrows show parallel. What about this one? This is a rhombus. And what about this one? Parallelogram. Okay? Now, over here it says find the measure of each angle indicated. And it's wanting us to find angle V. So, I don't want to do that. Angle V is right here. Sorry. Okay. All four of these together have to add up to what? 360. So 8x minus 4 plus 12x minus 2 plus 116. What about this one here? 90. That's 90. Please don't forget to put in the 90. And that all has to add up to 360. You are going to combine your like terms. So 12x and 8x make 20x. This was the same one from yesterday. I forgot to change this one. Sorry. Negative 4 to negative 2 is a negative 6. 110, 16 plus a negative 6 is 110. So this is 200. Hope the other ones I changed. Sorry. I think I did change the other ones. I hope I did. Oop, I put an extra 0 there. Did I change the other ones? Okay, good. It's just this one that I forgot to change. divide by 20. What does x equal? 8. And to find angle V, we would substitute in. The measure of angle V would equal 12 times 8 minus 2, which is 96 minus 2, which is 94 degrees. I almost felt like Groundhog Day for a minute there. Okay, what about these? This one was the same too, but this one's not. Oh well. But this one isn't, right? Okay. So when I need to find this one. The problem is I don't have any information to find this one. I do know these two angles have to be equal because they are opposite. I know that the adjacent ones have to add up to 180. So this would be like a 3-step problem. You would find x, substitute x either into p or r, and then take that answer and subtract it from 180. Do you see how this is multiple steps? It's a little bit different. I like this problem, makes you think. So 37x plus 3 has to equal 39x minus 3. I subtract 37x from both sides. I get 3 on this side is equal to 2x minus 3. I add 3. 2x is equal to 6. Divide by 2. X is equal to 3. I can find one of these angles, P or R. I'll choose P. So to find angle P is equal to 37. The measure of angle P is equal to 37 times 3 plus 3, which is equal to, is it 114? 37 times 3 plus 3. Yes, you all are great. So that's 114. We know that angle Q then would be 180 minus 114 would equal angle Q. So what is 180 minus 114? So 66 degrees is the measure of angle Q. That one you had to do a few steps. This was the same as yesterday. Sorry about that. I think it's the same as yesterday. I just remember a 15x. What do you know about the angles that are next to each other like this? Consecutive. What? They add up to 180. Across or opposite in parallelograms are equal. Adjacent or consecutive or next to each other, however you want to say it, that has to have a sum of 180. They are supplementary. So 15x plus 10x minus 5 has to equal 180. 15x plus 10x is 25x minus 5 is equal to 180. I add 5 to both sides. 25. Oh, is that a plus or a minus? Up here. Oh, it's a plus. I'm sorry, from my eyes, I thought it said, and that makes more sense. So I was like, 25 doesn't go into 185 equally. So then I re-looked. Yeah, I didn't see this little plus there. That was a plus. So x is equal to what, 7? And then I need to find angle x. So the measure of angle x would be 10 times 7 plus 5 which is 75 degrees. Right? Okay. I think our test will be Monday. Today we're going to review, we're going to learn how to find area of regular polygons. I want an extra day because that's a little bit longer lesson just for extra practice. So I'll probably do board practice like we did before, that one day that everybody liked for review. And then we have a popcorn activity for when we get into volume. So tomorrow will be kind of a fun day, I think. That's just me. We all love popcorn. Anybody here not like popcorn? Okay. So be here or be square. Okay. No, we're going to be on the board for review, and then after that, we're going to do a volume activity on popcorn. Okay, that will lead into our next unit. Right here, I have centimeters, millimeters, centimeters. So I want to make sure that I'm going to be using the correct units. They all have to be in the same unit when you're calculating area. So I'm going to have to do a conversion maybe. First of all, what shape is this so I know what formula to use? This is a trapezoid. Trapezoid formula is A equals B1 plus B2 times height divided by 2. Very good. If I don't know what shape it is, it's pretty hard to figure out what formula to use. And centimeters in CUDA, they always have you go to the highest unit. And the largest unit would be centimeters. So I'm going to convert 89 millimeters to centimeters. Does anybody know how many millimeters is in a centimeter? 10. And since I'm going from a smaller unit to a larger unit, I'm going to divide. If you did not know that, you could set it up as a proportion. 1 centimeter is 10 millimeters. I have millimeters on the bottom here, so I'm going to put 89 millimeters. And then how many centimeters? When you cross multiply, that will give you your answer. So 10x equals 89. So you just divide by 10, and that would be 8.9 centimeters, right? Jordan, we're doing better with
Yeah.
okay, making better sense. Okay, good. Um, so what is base 1? What is base 2? What is height? This one's height. And base 1, base 2. It doesn't matter which one you call base 1 or base 2 because I'm just adding them together, right? What about this 8.8? That's extra information. Good job. I'm not going to use it. That's what makes this high school level is the conversion and putting in extra information. If I just gave you a normal trapezoid finding area, that's 5th grade work. Okay, so 3.5 plus 8.9 times 7.5 divided by 2. Make sure when you divide, when you do this, if you don't use parentheses, you press enter after you add, or it messes the problem up. Or just use parentheses. So like this would be 3.5 plus 8.9 times 7.5. I get that answer, and then I have to divide by what? Divide by 2. And so this answer would equal 46.5 centimeters squared, because it's an area unit. Except I just ran into the other problem. Let me redo my circle so I can actually see that number. Okay. What shape is this one? Parallelogram. And a parallelogram is area equals base times height. Base times height. Right? Okay. So, and I have feet, I have feet, I have feet, but this one's in inches. What would I divide 132 by to change it to feet? How many inches are in a foot? 12. Please divide this by 12. What is 132 divided by 12? Is it? Okay, thank you. So this would be 11 feet. And where's the base and where's the height? Yeah, this would be your height, and then it's drawn because here's the right angle, and it's drawn to the base. So this is base. So all I do is take 6 feet times 11 feet, which is equal to 66 feet squared. And that is area. Okay, number 11. What shape is this one? Is a triangle. So I have base times height divided by 2 is equal to area. Again, I have feet here, but here I have inches. So I have to do a conversion. You want to divide this one by what number? We just did it up here. By 12. And so 37.2 divided by 12 is 3.1. So I would use 3.1 for my height and 3.1 for my base. So 3.1 times 3.1 divided by 2 would give me area, right? So 3.1 times 3.1 is 9.61 divided by 2. And that's, we will round that to 48.8. And what unit am I in? The 4.8 is feet squared. Okay, so number 12. Number 12, they gave us area. I need to find a missing unit here. This is a triangle. We have height. We're trying to find base. What is the formula for a triangle again? Area equals base times height divided by 2. I have area 30.2 inches squared equal to 5.7 times the base divided by 2. I can multiply by 2 on both sides to clear the fraction. This would be 60.4 is equal to 5.7 times the base. You divide by 5.7, divide by 5.7, And base would equal, what is 60.4 divided by 5.7? Ooh, 10.6? 10.6, and that'd be in inches. Okay, one more. What shape is this one? Parallelogram, which the area formula for a parallelogram is base times height. I'm looking for the height. I have base and I have area. So 16.2 centimeters squared is equal to 6 times h. So I divide by 6, and h is equal to what? What is it? No, that can't be right. 2.7? 16.2 divided by 6? Oh, okay. I guess you're right. Okay, thank you. Um, okay, this is asking for one interior angle. For these, you have to read the directions to determine which formula you use. If I'm finding one interior angle, you would use n minus 2, and I would divide that by n because I'm looking for each one. And it's a regular dodecagon, so each angle is going to have the same measure because regular means same side lengths, same angle measures. So how many angles does a dodecagon have? Well, how many sides is it? This is 12. So this is 12 sided. So n is equal to 12. So I substitute 12 minus 2 times 180 divided by 12, which gives me 10 times 180, which is 180 times 10, we just add. So I divide by 12. What is it? 150 degrees. So each angle would be 150 degrees. Right? Okay, now this one says sum. Sum means you would not divide by n. They want what the total is. So this formula is n minus 2 times 180. Right? Okay, if it's a 19 gone, that means n is equal to 19. So I just do 19 minus 2 times 180. So 17 times 180. What is 17 times 180? 3,060, like that, and degrees. And that'd be the total because it says sum. And then the next one, oh, it's a dodecagon again. We already know that's 12-sided. Does anybody know how to find exterior angles? What formula is that? 360 divided by n, which is equal to 360 divided by 12, which is what, 30 degrees? Which makes sense because if the interior is 150, the exterior would have to make a straight line, 150 plus 30 is 180, which makes that straight line. Your interior and exterior angles should always add up to 180. Make sense? Good. Okay, so today we are learning about regular polygons. Going to learn a new vocabulary word. And we have to go back to trigonometry and special triangles to be able to do these. We're going to do a little review of special triangles. And trigonometry. Those are some of us in late. Okay, so I should grab one because sometimes it's a little different on the screen. Okay. So today we are going to be able to find areas of regular polygons. So when I did my mat workout yesterday, because I'm starting to work out, it's healthy for you. You all should exercise. I'm feeling so much better. I'm laying on the ground on my mat, my brand new yoga mat, and it has pretty hummingbirds on it. And I look up at the ceiling, and there's hexagons. They have these huge hexagons. And I was like, wow, that's interesting because I bet you someone had to find the area of those to figure out where they're going to place them on the ceiling. And then I thought I should have taken a picture so you all could have seen the huge regular hexagons on the ceiling where I worked out at. But I didn't. Maybe I'll be in there tonight. Maybe I'll try and take a picture. It's dance fitness tonight. In New Pal. I go to the Hancock Wellness Center. My daughter's been dragging me, and I thanked her today. I was like, I'm glad you care about my health because now I'm starting to feel better. And I feel less stressed. You all should do that. Sometimes we don't think about exercise and we think we're too busy, but you really should squeeze it because you end up having more energy. Okay, but I don't know what that is doing with. Oh yeah, because it had a big hexagon on the ceiling. Okay, that's what it had to do with this lesson. Um, we'll have to remember how to use special triangles and trigonometry because we'll have to find missing lengths to be able to calculate area. So, does everybody remember our special triangles? The pattern for 45, 45, 90 was A squared 2. For 30, 60, 90, it was A squared 3, 2A. Some people were writing the wrong, it wasn't just like one or two. There were a few of you that wrote 2A right here. Yeah, don't do that because then you get the wrong answer. But you were not the only one, Jordan. You were not the only one. Um, okay, so if I have a 45, if I know this is 45 and this is 90, this has to be 45 because it all has to add up to 180, correct? So 45, 45, 90, A square root 2. This just follows the pattern. What's A if across from the 90 is 5 square root 2? What's in front of the square root 2? 5. So A is 5 since this was 5 square root 2. Now you could have gone A square root 2 equals 5 square root 2, divide by square root 2. Do I have to do this? No, the whole reason about learning the patterns is to save time so you wouldn't have to. That hopefully you just look at this and go, oh, that's 5. And this is 5. And I can move on with the rest of the problem. What about this one? This is 30, if this is 60, and so 30, 60, 90 is a square root 3, 2a, and across from the 90 is 16. So if across from the 90 is 16, 2a equals 16, so what would a have to be? 8. A would have to be 8. And once I have 8, it makes my job easy because this would be 8, and then I just substitute 8 square root 3. So this would be 8, and this would be 8 square root 3. Is it all coming back to you? Good. And then, of course, SOHCAHTOA. Now, if you hate special triangles, which I know some of you do, you could always use SOHCAHTOA or your trig functions. Yeah, you could just use SOHCAHTOA if you want. Remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And if we don't label correctly, we get things wrong, right? And I know why you're laughing. Because my inappropriate way to remember it. Okay, is that why you're laughing? I can read minds. Isn't that interesting? Okay, so here's 75 degrees. I put my finger on 75, and now I mark up my triangle, right? So if across from the 75, what do I call the 16? Opposite. And then I look at the 90, and I call this one hypotenuse. And then the leftover one is adjacent. I'm looking for hypotenuse, and I have opposite. Which one uses opposite and hypotenuse? Sine. So is sine equals opposite over hypotenuse? No, we do not sit in math class. Sine 75 is equal to 16 over x. X is in the bottom, so that should mean that some of you notice that pattern that you end up dividing, because when I cross multiply, I get x sine 75 is equal to 16. So I have to divide by sine of 75. And my calculator always reverts the mode, so when I turn it off, so I'm going to change it, make sure I'm in degree.
So we divide, we divide and multiply
You multiply when x is on the top.
Yeah.
You divide when x is in the bottom. So 16 divided by sine 75 is equal to 16.6, right? And because of rounding errors, I may write this on my paper, but you really should go out further. I'm going to explain that again. You only round to at the very end. So if I were to work this out, I probably wouldn't use 16.6 when I'm doing the math calculations with this. So that way I don't get rounding errors. I would probably go 16.56, what was that, 4. I would probably go out like 4 decimal places, right? Now, Jordan, weren't you the one who was saying that a lot of machinery is doing surgery now, like robotics? So my husband was working on some of that machinery. He does a lot of software. He does what's called embedded software, where he's programming for robotics type of stuff. And the accuracy had to be within a diameter of one of your hairs. So think about pulling out your hair and it being a cylinder and having it to be that close in accuracy because you're going into like arteries and things like that. Yep. Okay. So why don't you all work on this one? And I'll walk around and see if you remember your sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent is equal to opposite over adjacent. And if anybody during lunch wants to make a pretty like poster with one of those about special triangles and trig, I'll give you some bonus if you're like artsy. Okay, so yes, this one ended up being cosine, opposite, adjacent, hypotenuse. You were looking for hypotenuse, you had adjacent, so that's cosine 48 is equal to 15 over x. You end up having to cross multiply. So x cosine 48 is equal to 15, and then just divide by cosine 48. And you end up getting like 22.4 for your side length. Now, when we use this, we're going to go out 4 decimal places, though. Okay. And then which trig function did you get for this one? This was tangent. It should have been tangent 59 degrees is equal to opposite over adjacent, which is x over 17. So this one would just be multiplication. And Mary, what did you get for that answer? 28.3. Like I said, though, for these next problems, we won't round to the 10th. We'll go out like 4 decimal places. Okay, so we're learning a new vocabulary word today. Opossum. It's not an animal that comes out at night and looks really ugly like a possum. This is called a opossum. An opossum it's a distance from the center of a regular polygon. The key word is regular, meaning every side and every angle has the same measure. And it's perpendicular to the side, which means creating a right angle. Just tells you why the formula works. Because I know there are people out there that they have to know why a formula works. So this is if you were doing it manually and cutting these into congruent triangles all the way around. So you'd have 8 congruent triangles. You'd find the area of one triangle, right? And then multiply it by 8. But to make it simpler, they give you this formula. The area of a regular polygon is equal to 1/2. When I use 1/2 in my calculator, I use 0.5 just because it's easier to put in the calculator. times apothem, which is the distance from the center to one of the sides at a right angle, times the perimeter. What is perimeter again? The sum all the way around. Okay? So, if I'm looking at these, we know that the formula, because this is a regular polygon, is 1/2 times apothem times perimeter, right? So, what's the apothem? 7.3. And it didn't give us any units. What's the perimeter? Perimeter I have to calculate. It's going to be 10.6 times what? Times 5. Because it's all the way around, so it's the side length times the number of sides. And there were 5 sides here. So what is this one? 53? So now I could substitute everything into the formula. Area is equal to 0.5 times 7.3 times 53. And so what do we get for that? What is it? 1093? Oh, sorry. Let's try that again. 193.45. We'll round that to 5. And we don't have a unit, so I'm going to put a little unit squared. Unit just means like inches, centimeters, whatever. Okay, so over here, this is a regular polygon. Area is equal to 1/2 times apothem. I'm just going to use a little a for apothem times capital P perimeter. Reason why I use capital P is there's an operation I have to do to get perimeter, where apothem is just pulling it off, pulling that information. So, what's the apothem? 7. What's the perimeter? Is it 72.6? And you got that by taking 24.2 times 3, right? Because there's 3 sides. So these are the 2 I'm going to use in the formula. So I would do area equals 0.5 times 7 times 72.6, which is equal to units squared. Okay, now these were easy, right? And in math, do we always keep it easy? Oh, we always throw something in there to make us think a little harder. And so right here, okay, sorry about that. So down here, I'll wait until everybody. Okay, so you'll definitely want my templates for these. Could someone grab those and pass them out? Make sure everybody has one. You definitely want one of these. Okay. You may only be given one side length or the apothem. And you'll have to use central angles and special triangles or trigonometry to find the other length needed. I'm waiting until she delivers some out. Okay. You'll need to draw triangles and cut the triangle in half with the apothem. So if I was doing this problem here, this is a 1, 2, 3, 4, 5, 6. This is a hexagon. Everybody agree with that? Okay. To get this central angle right here, it says you need to take 360 and divide it by the number of sides. This is why we talked about rotational symmetry yesterday, so you could understand why this works. Because each of these triangles are equal, you could think about this being a circle and rotating in a circle going around, right? So each of these angles here would have to be 60 degrees because 60 times 6 is 360. Basically, you just took 360 divided by 6, and that gives you this central angle right there. Now, the apothem is when you draw a height from the center to the opposite side. It turns out that the height of any of these triangles here is the apothem. So right here, this side here is your apothem. To cut this triangle in half, right? So instead of using 6, what is half of 6? What's 6 divided by 2? 3. That's why you see a 3 here, because we had to cut everything in half. What's half of 60 degrees? 30. What's half of 6? 3, right? So this follows your 30, 60, 90 pattern. So this apothem would be across from the 60 degrees, because here's the 90. And all I care about is the apothem, because I have the silent. Getting perimeter is going to be easy. It's figuring out what the apothem was. Well, if across from the 30 is 3, then across from the 60 is going to be 3 square root 3. Right? Because remember, a square root 3, 2a. This was across from the 30, 60, 90. This was 3, so this has to be 3 square root 3. Now I have apothem. What does apothem equal? 3 square root 3. How do I find perimeter? Perimeter, 6 times 6. 6 times 6 is 36. So now I have enough information to find the area. It would be 0.5 times 3 square root 3. Don't forget to push out so you don't stay underneath this radical, times 36. So if I was doing it on my calculator, it would look like, I'll move this out of your way here. It will look like, I'm trying to move it out of your way. 0.5 times 3, and then I have to hit my second button, and 3. I'm going to close this parenthesis to say I'm done with that radical, right? Times 36. And I get 93.5. Now I can round. I wouldn't want to get this 3 square root 3 and then round at the end, because then you get what's called rounding errors and you're off by a little bit. But now I can round because I'm done. And the area of this would be 93.5. And since it didn't give me a unit, I'm going to put unit squared. Whatever unit they measured in, it'd be unit squared. Ah, here you're trying to take a picture and then that pops up. Now, I don't mind you taking pictures, but studies proven. Oh, you don't have this one in your notes. That's why you're all taking pictures. Now that makes sense. Okay. This one, is this one in your notes? No, yes, I'm getting lots. Yes, it is. It's the one, it has the steps printed out. It just doesn't show all the work, right? Let me see. Does it have, oh, they locked the other ones. They're going to force me to pay the $100 a year. Darn it. Okay. This one I just left. We're going to get the decimal form of it, but I'm going to walk you through the steps, okay? I wonder if I can pull up paint. Hold on a minute. Let me see. I wonder if paint does it for me. It does. See, why would they lock it when paint doesn't? Okay, right? It was a hexagon, correct? And this is 16. So this is 16. Why isn't it writing? Oh, come on now. 6. Why isn't it writing for me? Okay. Oh, no. Now it's starting to write. 66. Oh, this is so weird. It's not writing. Okay, well, I'm going to have to just go off of what's here. Sorry. Okay, so right now I want everybody to draw a triangle inside their hexagon, like this. Everybody see, we're on this one right here, right? Everybody right here? And you're drawing a triangle. What is this? And the steps are written out for you right here. Look at how nice I am. So you're going to draw a triangle from the vertices to the center of the polygon. Here's a vertice, right? Here's the center, and I draw that triangle. I know this is 60 degrees. How do I know it's 60 degrees? Right, because the number of sides is 6. That means there would be 6 triangles all the way around. And if I'm rotating, it'd be a 60-degree rotation, like we learned about yesterday. Now, I always draw a separate triangle because sometimes I don't have enough room to work in this triangle. So I draw a separate triangle on the other side. And I cut that triangle in half. So draw this right now. You all have templates, right? You have little triangles you can use on the templates, or if you're good at drawing, you can just draw it. Daniel, the notes are over here. Israel will hand it to you. Well, because you're cutting the triangle in half, half of 60 is 30, half of 16 is 8. And then you use your special triangles to find that the apothem is 8 square root 3. Once you have the apothem, you calculate perimeter by taking 16 times 6. Why am I using the number 6 here? Because there's 6 sides. And so perimeter is going to be 16 times 6 because of the 6. I mean, you could put 16 plus 16 plus 16 if you really wanted to 6 times, but it just makes sense just to multiply this by 6, and that is perimeter. Once you have perimeter and we have apothem because if this is, if opposite of 30 is 8, this is 60 degrees here. So opposite here would be 8 square root 3 based upon special triangles, right? And so apothem is 8 square root 3. Once you get the apothem, you substitute everything in. 1/2 times 8 square root 3 times 96. I think I just did 1/2 times 8 is 4. 4 times 96 is 384. And I got my square root 3. This would be the exact answer. If I wanted it rounded, it would be 384 times, hold on 1 second. You get, what's 16 times 6 for the perimeter, right? And so we could also say this is approximately 665.1. It didn't give us a unit, so unit squared. Now it seems like it's hard, but the steps are written down for you. If you follow the steps, it's like baking a cake. If you follow the recipe, you'll have a yummy cake at the end. If you put salt in the cake instead of sugar, you're going to have a really yucky cake at the end, right? So you follow step by step. So we're going to do one together right here, okay? How many sides is this? 6. So I'm going to first draw my triangle, right? And if I take 360 divided by 6, it gives me this angle because it can rotate around, which is equal to what? 60 degrees. So I like drawing a new triangle so I have enough room to work. So this here is 60, but I have to cut this triangle in half because I need the apothem. And remember, the apothem is perpendicular to the opposite side from the center. And that ends up being the height of this triangle, right? So if this side was 10 and I'm cutting this side in half, how much is this side? 5. This length is 5. Now this is 30 degrees, right? Because half of 60 is 30. If this is 30 and this is 90, what's this angle measure here? That's 60, right? 30, 60, 90. And according to our 30, 60, 90, we have a square root 3, 2a. And across from the 30, A is given, that's 5. So what is the apothem going to be? 5, yep, 5 times root 3 or square root 3. I don't care what this side is. I only care about the apothem. So apothem is 5 square root 3. How do I find perimeter? 10 times 6, which is 60. And now I can apply the formula. I have apothem. I have perimeter. So area is equal to 1/2 times apothem times perimeter. So 1/2 times 5 root 3 times 60, which would be, what is that, 100 and, yeah, I was going to get the exact answer first. So that'd be 30, would be 150 root 3, or now go ahead and give it to me. What'd you get? 10 times 6 is 60, because 10 is my side length, right? Because the side length changed. It's basically the same as above, but the side length changed. What did you get for 150 square root 3?
259.8 units squared.
0.8 units squared. Okay. Okay. Now, figure it out? Are you still? Go ahead. Excuse me? How to get 5 square root 3? It was the special triangles we learned before. And so if across from the 30 is 5, A is 5. Across from the 60 would be A square root 3. Since A is 5, you would put 5 square root 3. Remember from previous work? Now do we understand? You thought you could forget the special triangles after the test, and you can't because we use it again. Make sense now? Can I move on to the next one? Well, yeah, that's the. But if you follow, the steps are written here. I can't make it any more clear. As long as you go step by step, you're fine, right? Aren't the steps written down for you? Yeah, they are. They're right here. They're right here. Steps finding apothem and area. It's 1, 2. It just missed 3, 4, 5. Yeah, it does. 1, 2, 3, 4, 5. It's just it accidentally cut them down. Yeah, those are the steps. Yep, the steps are written there. And then I have the steps for the trig written down. Okay, now this would be if I had used trig. Really, with the special triangles, I think hexagons are the only ones because they have to be a certain angle. You'd have to be 60 or 120. Over here, and you could use trigonometry for all of them. So if you do not like special triangles, just use trigonometry because trig works for all triangles that are right triangles. And all these will be right triangles because the apothem is a right angle. So the steps again are written, right? It says here, steps in finding the apothem and area. Draw a triangle from the vertices to the center. So right here, I draw my triangle, right? See how I draw a triangle? Now this triangle, how many sides is this shape? One, it's a 12-sided figure. So I'm going around 12 times. So that rotational symmetry or this central angle would be 360 divided by 12. So to find this was 360 divided by 12, which is 30. Now, I draw a bigger triangle because this little triangle it's too small to work with. So use your templates, draw a bigger triangle. There should be enough room on there. And you draw an apothem. This apothem is the height of this triangle. The apothem of this figure here, this regular dodecagon, is the height of this triangle that you are drawing. However, when you draw the apothem in, you're cutting the triangle in half, right? So if this is 2 yards, this whole thing here, what's from here to here? 1 yard. And if this whole angle is 30 degrees and I cut it in half, this is 15 degrees. Well, now I'm going to use trigonometry. Here's my finger on the 15. This would be opposite. This is hypotenuse. And this is adjacent. Adjacent's actually the height of this is the apothem. You agree? Okay. Well, which trig function uses opposite and adjacent? Tangent. So I would set this up as tangent 15 degrees is equal to opposite, which is 1, over apothem or adjacent, which is, I'll just put an A for the apothem. I need to cross multiply. You get A times tangent 15 is equal to 1. And you have to divide by the tangent of 15. And when we're doing these, so you don't get rounding errors, go out to 4 decimal places. What is 1 divided by tangent 15? 3.7331. Oh, 2, 1. Okay. This is what I want you to use, not the 3.7. So we don't get rounding errors. So now this is apothem, right? That's your apothem. How do you find perimeter? Perimeter would be 2 times the number of sides. How many sides do I have is 12. So that is 24. So now I can I'm going to try and see if there's more room here. So now I can do my area formula. Area is equal to 0.5 times, but I'm going to use this long one, 3.7321 times 24. So I don't know if this is is going to be the same because I may have rounded when I did this one. However, then you don't get the same answers on your answer key, and then students get all freaked out. So now I tell people to go out 4 decimal places. And this, see how different we are off? Because this one I use that's rounded, but this one's more exact. This would be more the correct answer here because I didn't round until the end. So really, if I was looking on the back of a CUDA worksheet, it would say 44.8, not 44.4, because I rounded too early here. Does that make sense? That's why we're using this longer decimal right here. So the real answer is what? 44.8 yards squared. Now I can round because I'm at the very end of the problem. Okay, so I'm going to help you with this one. I'm going to jump to this one and do this one with you. Then I'm going to walk around to make sure everyone can do this one. Is that fair? Okay. The reason why I want to do this one is the side length isn't given. What's given? Perimeter. How would I find the side length if the perimeter is 15? Yes, because there's 5 sides. To find the side length, 15 divided by 5 would equal what number? 3. So this side length is 3. And if I draw my triangle, okay, I'll be sending this video to you. Do you want the worksheet before you leave? Okay, so, sorry. So now I draw a new triangle just so I can work with it because this is too little of an area. I draw an apothem, right? This height of this triangle is the apothem of the pentagon. If this whole length is 3, what's half of 3? Yes, this would be 1.5. To get this central angle, what is 360 divided by 5? So, and then I have to divide it by 2 to get this angle right here, which would be 36 degrees, right? Now, I'm going to use trigonometry to find this apothem. So 36, this is opposites. Hypotenuse is here, but I don't care about the hypotenuse. This is adjacent. What trig function am I going to use? Tangent. So tangent 36 is equal to 1.5 over, and I'm just going to call this A for apothem. I cross multiply. Yes?
Why are we using tangent of 36? Shouldn't we?
What did she tell me this was What was 360 divided by 5?
Are we using?
Hold on a minute. Let me.
Wait.
Okay. So, well, unless you gave me the answer ahead of time. Okay, so 360 divided by 5 is 72 degrees. Then you divide that by 2 because you're using half the triangle, which is 36. You're good now? Okay. So now I cross multiply and I get tangent, or A times tangent 36 is equal to 1.5. I divide by tangent 36, and A is equal to what? 2.0646. Thank you very much. Um, and now I have perimeter. Do I have all the information to find? And this is in inches, so I have apothem, I have perimeter. Now I could substitute in. Area is equal to 0.5 times apothem. I'm going to use this decimal that goes out for place value so I don't get rounding errors, times perimeter. And what's perimeter? 15. And my answer would be in inches squared because it tells us it's in inches here. Area is equal to, now I can round. So, what did we get here? 0.5 times 2.0646 times 15, which is 15.5 inches squared. So I'm going to let you go to break. When you come back, I want everyone to try this one, and I'll walk around and check to see if everyone gets it right. And then I will give you your worksheet to practice. Tomorrow, we're going to practice. I'm going to have you do board work. We're going to do the properties of quadrilaterals. We're going to do area formulas, which will include this. And we have our popcorn activity. Monday test. I just wanted to give you more time to practice finding, because I know these steps take a while. That's why I didn't want to do a test tomorrow, because I wanted you to have plenty of time to practice. So Monday test. After test on Monday, we will be putting together nettings. We're going to be cutting out and putting together 3D figures, and we're going to get into volume and surface area. Okay? So go ahead and go to break. So for this one, I hope you try to do it yourself, and then just use this to check your work. I was going to do this. I'll be over there. I'm actually doing it on the board here. Did you get 377? Or did you have a different question? Okay, did I give you this? Oh, okay. Did you have a question on this? Oh, I'm going to go ahead and draw my other triangle. I know that when I have this one, that the central angle is going to be 360 divided by the number of sides. There's 10 sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is 36. So this whole angle is 36 degrees. When I cut it in half, this is 18 degrees. 7 was this whole side length. So I have to cut that in half, which would be 3.5. Once I have this, I'm going to have to use trigonometry to find the height of this triangle, which is the apothem. Well, this is opposite, this is hypotenuse, and this is adjacent. So I have opposite. I'm looking for adjacent, which would be tangent. So tangent of 18 degrees has to equal 3.5 over the apothem. I cross multiply. Apothem is equal to, oh, sorry, I jumped a step here. Apothem times tangent 18 is equal to 3.5. So I divide by tangent 18, which is equal to, I'm going to check my mode, just be on the safe side. I'm good. So that would be 3.5 divided by tangent 18. Because of rounding errors, I'm going to go out 4 decimal places. So this would be 10.7719 because that 8 rounded up to a 9. So this is the apothem. Perimeter is the length times the number of sides, which is 70. And now I have all the information to find the area. I'm going to try and squeeze it in over here. Area is equal to 0.5 times 10.7719 times 70. That's not degrees. It's 70. I don't know why that was there. And then when I do that on my calculator, I get 377.01, which to the 10th place would be 377.0 inches squared. And that's that.